We are going to look at how do we write the solution for a question where you are asked to find inverse of a given function. All of you are familiar with what we mean by inverse of a function. Let's start with a quick recap. The definition says that a function f defined from set x to set y is defined to be invertible if there exists a function g from set y to x such that g composed with f is identity on set x and f composed with g is identity function on set y. We say in that case g to be the inverse of f and denoted by f inverse. We also know that a function is invertible if f is 1, 1 and onto. Conversely, if f is 1, 1 and onto, then f must be invertible. Let's see if we can take a question and apply both of these definitions one by one and try to show that a given function f, as in this case from real numbers to real numbers, defined by f of x is equal to 2x plus 1, is invertible and how do we find its inverse. Again, the first definition here is based on the idea of finding a g such that g composed with f and f composed with g turn out to be the identity function on the respective sets. At the same time, you have the option of showing that the function is 1, 1 and onto and hence establish that the function is invertible and also decide on the inverse of f. Right now, we will follow the first method. That is, we are going to find a g and then verify that f composed with g, g composed with f results in identity function. To start with, if y is equal to 2x plus 1, then x must be equal to y minus 1 over 2. So to write that down, you start with let y belong to R and y be equal to 2x plus 1. From here, x would be equal to y minus 1 over 2, which also is a real number. Now start with defining the g, which is going to be tested for the composition. So we start with g to be a function from set R to R. Note that f is also a function from R to R. Had f be a function from A to B, you will take g to be a function which is going to be defined on B and it is mapped to set A. So in this case, g of y is equal to y minus 1 over 2. Now to start with, let's take an x which belongs to the domain of f. So x belongs to R be any real number belonging to the domain of f. So again, if the domain of f was set A, then this x will belong to set A. So g composed with f of x is to be evaluated, which is same as g of 2x plus 1. And g takes every element that comes under it to 2x plus 1 minus 1 by 2. And therefore, the final output is x. Now, this is true for any value of x belonging to the set R, which is the domain of f. And therefore, we conclude that g composed with f must be the identity function on this set R. And again, at this point, many of you go wrong and you write that g composed with f of x is identity function on set R. So please be careful that there is no x coming in this case because this is I, which is the name of the function, not the value of the function at x. So do not write g composed with f of x to be equal to identity function. The next step is again very simple. You will take now an element on which g is going to act. So to find f for g of y, where y belongs to R, that is the domain of g, we have the rule that it's same as f of g of y. G of y is y minus 1 by 2 and therefore f takes it back to y. So we say that f composed with g is also identity function but on the set R, which is the domain of g. And so from 1 and 2, we are ready to conclude that function is invertible and g is inverse of f. At the same time, you are asked to find inverse of f. So conclude by defining the rule incomplete. So f inverse is a function from set R to R. F inverse of y is equal to y minus 1 over 2. In our next video, we will look at the same question and do it with the second method.